Good evening, everyone. Here I'm Amit Gupta. So today we will see one of the chapter of class 10 mathematics CBSE, that is real numbers. So first of all, I would like to give a brief introduction about the real numbers. What are real numbers? So before that, let us try to understand some numbers which you already know. That is natural number. We all know natural numbers are the counting numbers. That is 1, 2, 3, 4, and so on. Second is a whole number that includes 0 also with a natural number. So it starts with 0, 1, 2, 3, 4, and so on. Next is integers. Integers are what? These are the combination of the natural number and the whole number with negatives also. So examples: -3, -2, 1, 0, 1, 2, 3, and so on. Next is a prime number. Now prime number, we need to understand what a prime number means. Numbers which has got only two factors are called prime numbers. For example, 2. 2 is a prime number. Why? Because 2 has got only two factors. That is, the factor of 2 are 2 and 1. It's the 1 and number 2 itself. Similarly, 3 is also a prime number. It has two factors, 5, 7, and so on. So prime numbers are those numbers which has got two factors. Similarly, this composite numbers are the numbers which has more than two factors. Right? For example, 4. 4 has got how many factors? 4 has the factor 1. 4 is divisible by 1. 4 is also divisible by 2. 4 is also divisible by 4. Right? So 4 has got three factors. So this is a composite number, because composite numbers are those numbers which has more than two factors. Right? Now what about number 1? Number 1 is prime or composite. Now to be a prime number, it must have two factors, and for composite number it must have more than two factors, but number 1 has just one factor. So number 1, this 1 does not fit in any of these two category. That is, 1 is neither prime nor composite number. So next, let us try to understand what are real numbers. Real number means what? So basically what are real number means whatever numbers you can think of, any kind of numbers, natural numbers, whole numbers, integers. Numbers can be in fraction, number can be in decimal, number can be like root over 2, cube root over 7, all these kinds of number, whatever number we can think of, all are called real numbers. So let us try to understand what are the real number in detail. So what are real number means? It is a combination of rational numbers as well as irrational numbers. So what is a rational number? So this is very important to understand what is a rational number. Rational number means those numbers. Let us denote that rational number as x. So rational numbers are those numbers which we can represent in the form of p upon q. Those are called rational numbers. Now some condition is there. Your q should not be equals to 0. And moreover, this p and q must be integers. P and q must be integers. Now why q should not be 0? What happens when q is equals to 0? So let us see one example. Suppose I am writing 2 over 0. Right? So I want to explain why q should not be 0. If q is 0, then what happens? It looks like this. For example, I have taken numerator as 2 and denominator as 0. For example, if you have a test and test is of 0 marks, which is not possible, and suddenly you are getting 2. This is completely meaningless thing. That is why this is not possible in mathematics. So this is Nothing but this is not defined only. This is not defined. In other words, also you can understand this means that 2 we have to divide in 0 parts, which is completely impossible. I cannot divide 2 in 0 parts because 2 is already 1 part, right? So 2 upon 0, it is not defined. Now rational numbers are those numbers which we can represent in the form of p by q with this condition: p and q must be integers and q should not be 0. Can p be 0? Yes, p can be 0. So for example, let us write some examples of rational number. We can write 0. 0 is a rational number. Why? Because 0 we can represent in this form. 0 can be simply written as 0 upon 1 or 0 upon 2 or 0 upon 3, right? 0 upon non-zero numbers. So 0 is a rational number. Similarly, I can write 2 upon 5, 3 upon 6, 7 upon 2, and etc. So all these are the examples of rational numbers. Now let us come back. So this natural number. So all this natural number we can represent in the form of p by q. For example, 2. 2 can be simply written as 2 upon 1. So 2 is also a rational number. So all natural numbers are rational numbers. Similarly, all whole numbers are also rational numbers. Integers are also rational numbers because we can represent in the form of p upon q. So here some example we can write on the rational number. So rational number, it is natural number. Some example let us write. So natural numbers. Then we can write whole numbers. Then we can write integers. Then we can write prime number, composite number, and so on, even, odd, and so on. All these numbers are rational numbers. Now, what is irrational number? If all these are rational numbers, then what comes under irrational category? So, irrational numbers are those numbers which we cannot represent in the form of p by q. That is, numbers which are not rational are said to be irrational. So what example? So in example we can have root over 2. Now root over 2 we cannot represent in the form of p upon q, because when you try to find the square root of 2 root over 2, this will not end, and hence we cannot represent in the form of p upon q. Similarly, another example we can write root over 3, root over 7, and etc. So don't assume that if the number is in the root, that is irrational number. For example, I can take root over 4. This is also on the root, but this is a rational number because this 4 can be simply written as 2 into 2, or I can write minus 2 into minus 2. So from here I'll get 2, or from here I'll get minus 2. So root over 4 is can be written as either plus 2 or minus 2. So plus 2 and minus 2 both are rational number. So root over 4 is a rational number. So do not get confused with the numbers which is inside the root are always irrational. It may be rational also, right? Now, few problems, let us try to solve it. Actually, my aim is to have a quick revision on this chapter for those who are appearing for this upcoming board examination. So for that, LCM and SCF concept, based on that, let us solve one problem. So if you have a little confusion about SCF and LCM, let me give one example to understand what is SCF and what is LCM. So example, let us take. I am taking two numbers, let's say 12, simple number I am taking, and second is 6. Now we want to understand what is SCF and the LCM of two numbers. So we can write 12 as 2 into 2 into 3. This is called prime factorization of 2. Sorry, prime factorization of a number, that is 12. So if it is a bigger number, so this is the way we can do it. 12, so 6 times, 3 times, 3 times and once. So 12 can be written as this. Similarly, second number is 6. So 6 can be written as 2 into 3, simple. Now what is SCF? So SCF of A and B. A is 6 and B is 12. So this is the notation we can follow to represent SCF of two numbers, that is 6 and 12. So SCF means highest common multiples. Now what is the highest common factor present in both the numbers? That is, one is 3 is there, 3 is present both in both the number, and 2 is also present. So SCF of this two number will be 2 times 3 is equals to 6. And then what is LCM? Now LCM means 6 and 12 LCM will be, we will take the highest common multiples also, and also numbers which are not common. That means 6 definitely it will come, because 6 is the common factor, and the one which is not common, that is 2. 2 will also come in LCM. So 6 into 2, that is 12. Again, here do not get confused with whichever number I am taking. Those are the SCF and the LCM. This is just a coincidence. So this is the meaning of SCF and the LCM of two numbers, right? Now when you look at this example, one thing we can construct from here, and that is very important. You can take it as a formula. From that formula also, some question can be there in the board examination. So when I multiply the SCF and the LCM, so let us multiply SCF and LCM. So what is SCF? It is 6. LCM, it is 12. So if I multiply 6 into 12, it is 72. Now again, if I multiply those two numbers which was given, so 12 into 6, that is also 72. And this is always true. That means from here we can write one formula, that is SCF of any two numbers into LCM is always equals to the product of the numbers. This is always true. So we will use this concept to solve this problem, right? So I'll erase this. And let us try to solve this problem. If two positive integers p and q are written as p equals to a square b cube and q equals to a cube b, where a and b are the prime numbers, this is very, very important. If it is not a prime number, then things will be different. These are the prime numbers, then verify that the LCM of p and q into SCF of p and q equals to p into q. That is what I explained just now. So let us find the SCF separately and LCM, and let us try to verify this relation. So A is given how much here? Not A, P is given. So P is given A square B cube, and Q is given your A cube B. Now what is SCF? SCF of P and Q. Now SCF means highest common factor. So from here easily we can say that what is a common? A square. Because A square is present in P also, A square is present in Q also. So the highest common will be A square. I cannot take A cube as a common because A cube is not present in P. because highest common factor means it has to be present in both the numbers. That is highest common factor. So that is a square, and b is here, just b is there in q and b cube is there. So what is the highest factor? This is only b. So if it is difficult to understand, you can always write this as a times a, b times b times b, and this we can write a times a into b. Now you can write whatever is common, that is the SCF. So SCF is this, that is what I have written, a square and b. So this is b. So this is the SCF of two numbers, and let us find LCM of two numbers p and q. Similarly, I explained you what is LCM. LCM means the common as well as non-common also. So what is common? Already we have found common is a square b. And what is not common here? So not common means these are not common and this is. So let us include that not common also. So here I can write b into b is b square and it is a. So finally I can write what is the LCM, that is a square into a, it is a cube, b into b square, which is b cube. So this is my LCM. Now let us simplify this. Okay, LCM into SCM. Now verify this relation. So first I'll take the left hand side, that is LCM into SCF. So left hand side I'll take it here. Left hand side will be LCM. LCM is how much? A cube b cube. SCF is how much? A square b. So this is a square b. Now if I multiply this, a cube into a square. If the bases are same sign, if the bases are same, power we must add. So this is a power 5 and b power 4. So this is the left hand side I am getting. Now what about right hand side? So right hand side is what? The product of the numbers PQ. So let us find PQ value. P it is given a square and b cube, and q it is given a cube and I think b, right? Now this is a square, a cube will be a power 5, b cube into b will be b power 4. Now I can see that these two are equal. So this is verified. So left hand side we got as right hand side, both are equal. So this is the solution. Let us look another problem. Okay, this is very interesting problem. This is very important problem. Generally this comes in CBSE every time. Most of the time CBSE asks this question: prove that root over 7 is irrational number, root over 3 is irrational number, or root over 11 is irrational number, root over 2 is irrational number. So let us try to prove it, right? So how to prove this type of problem? Now to prove this kind of problem, we will take one method, that is contradiction method. Now first of all, let us try to understand what is the meaning of contradiction. Contradiction means it is that mathematical statement which is not true. For example, if I say now it is 2027, that you will not agree. That means it is not true. So there is a contradiction. Contradiction means some statement which is never true in mathematics. That is a contradiction. So that method we will be using to find, to prove this number. Okay, that is root over 7 is irrational number. So what I will assume? So I will assume root 7 is rational. That is what I told you. Contradiction we will see. It is irrational, but I am assuming it is rational. Now suppose if I assume this to be rational, the properties of rational number has to be satisfied. Now let us try to see what happened. If this is rational number, then just now I explained you, if it is a rational number, I should be able to write in the form of P upon Q, where Q is not 0. And moreover, P and Q are co-primes. So co-prime, let us try to see here. Co-prime means, co means 2 and prime means prime. Does not mean that both number has to be prime. Co-prime means it's a set of numbers whose SCF is 1. Let us write one example. For example, if I write 2 and 3. So what is the SCF of 2 and 3? That is 1. So we can say that 2 and 3 are co-primes. In this case, 2 and 3 both are primes, but it is not, again, not necessary. So I'll give another example. For example, 4 and 5. 4 is not a prime number, but 5 is a prime number. Now, what is the SCF of 4 and 5? Again, SCF of 4 and 5 is again 1. So if this happens, then we say this 4 and 5 together, it is called co-prime. So co-prime are the numbers, it is a set of numbers, is a pair of numbers whose SCF is 1. Right? So I will so these are the co-primes. So these kinds of number we are talking about here, P and Q. That means we know that P and Q are co-prime. What does that mean? P and Q has highest common factor as 1. Very, very important, okay? Here P and Q has highest common factor as 1. But let us see what is happening here. If I cross multiply, so I can write P equal Q times root 5. Now if I do squaring both sides, squaring both sides. Now what happens if I do the squaring both sides? It will be P square, and if I do squaring both sides here, it will be Q square and root 5 square. So Q square and root 5 square will be 5. So I will not write the steps directly, I will write 5Q. I can write simply, right? Q square and root 5 square is 5. So this is what I am getting. Now from here, what can I say? From here I can say that P square over 5 equals to Q. Or I can say that when I divide P square with 5, it is completely divisible. That means P square is divisible by 5, I can say, right, from here. So this implies P square is divisible by 5. This also implies that if P square is divisible by 5, P is also divisible by 5. So we can also write P is also divisible by 5. So halfway we have already proved. P is divisible by 5. Now let us mark this as equation 1. Let us mark this as equation 1 and let us try to prove it something. Okay. Now if I put here, see here, P is equals to 5C. Now the question is why I am putting 5C. No, not 5C, 7C. Whatever number we have to prove, that we have to put, okay? Here it is given root 7, so I am putting 7C. If it was root 5, I'll put 5C. If it is root 2, I'll put 2C. Now what is C? C is the integer. C is any positive integer. Okay? C is any positive integer. Now where I am putting this P equals to 7C in equation 1. Okay, I have already marked it here, equation number 1 here. So let us substitute. Now maybe you may be thinking that why I am doing all these things. So my ultimate aim is to prove that q is also divisible by 5, right? What will happen then? P is divisible by 5, q is also divisible by 5. Then I can say that both is divisible by 5. That means I can say that P and Q has a common factor 5, which is completely not true because of the fact that I have taken P and Q to be co-prime, right? So let us put it here in equation number 1. So here equation 1, again I'll rewrite, this is 5Q. So I'm putting 7C equals to 5Q. No, 7 I'm putting. Here 7 I'll put. Okay. Now here it is. Oh, here I have done it. Sorry. This is not 5, it is 7. Okay. No problem. So all the proofs remains the same. Okay. So don't get confused. Okay. It is just 7. This is root over 7. So p square 7. P square is divisible by 7. P is also divisible by 7. Just replace 5 with 7. It is not an issue. Now, P square equals to 7Q. Now, let us substitute. P equals to 7C and 7Q. Right? Now, if I square it, this will be 49 C square 7Q. If I do, this is also square. Okay. Now, if I divide with 7 both sides, 7 1 7 7. So this will be 7 C square equals to Q square. Now from here what can I write? I can write C square equals to Q square over 7. Now from here similarly I can write Q square is divisible by 7. Because from here what I wrote, P square is divisible by 7. Similarly here I can write Q square is divisible by 7. If Q square is divisible by 7, Q is also divisible by 7. Q is also divisible by 7. Now this is almost we are done. Okay. Now see here, P is divisible by 7, Q is also divisible by 7. But actually it should not happen because of the fact I have taken P and Q to be co-prime. Right? P and Q to be co-prime. Okay. Here P and Q are co-primes. Okay. P and Q are co-primes. Here I can write P, Q are co-primes. There I explained you. Okay. Now here P and Q are both divisible by 7, which is not true. Right? Because already I have assumed P and Q to be co-prime. And what I got, P and Q has a factor of 7. So therefore, P and Q has factor of 7, which is not possible. Which is not possible because of our assumption. So this is not true then. What is not true? Our assumption is not true. That means assumption was rational, which is not true now, it has to be irrational. So this is the way of proving root 7 is an irrational number. Right? So same kind of question can be asked like this kind of question. Generally this kind of question also they ask like prove that 3 minus 5 root over 18 is an irrational number given that root 2 is an irrational number. So let us try to prove this question. This comes in 2 marks question. So let us try to solve it. Again, whenever you have to prove number irrational, we will do the same method, that is contradiction method. So contradiction method, what I'll assume? I'll assume 3 minus 5 root over 18 is rational. By the way, let us simplify this. 3 minus 5 root over 18. You may be thinking like here it is given root 2 is irrational number. So somewhere we have to use this fact. Root over 2 is irrational number. But root 2 is not appearing here. Let us simplify this. So let us simplify first. 3 minus 5 root over 18. So root over 18 can be written as what? Root over 18 can be written as 3 times 3, 2. So this will be nothing but 3 root over 2. Right? So this I can write 3 minus 5 root 18 is 3 root 2. So I can write 3 root 2. So I can rewrite the question as 3 minus 15 root 2. So this is my question actually. Little bit I modified, not modified, little bit I simplified. Now this becomes my question. So I'll assume this to be rational number. Then I will solve it. So now assume 3 minus 15 root over 2 is an rational, not an, is rational number. Is rational number. Now again, if it is rational number, same condition. This should be written in the form of P upon Q. So let us write 3 minus 15 root over 2 can be written as P upon Q because this is rational number. Now again here Q should not be 0. This is very important to mention. Q is not 0. Otherwise it becomes meaningless. Now in this type of problem, after this step, what we have to always do is to find the value of that root quantity which is given to you. In this case root over 2. So change the side and you find the value of root over 2. Okay. So now let us do it. So here what I will do, P and Q, P by Q I will take in the left hand side, that will be minus, and this I will take to right hand side. This is 15 root over 2. I want to find root over 2. So 15 I have to take it down. So before that let us simplify this. So this will be how much? Q is the LCM. So 3Q minus P equals to 15 root over 2. So in the next step I can write 15 will come down. So this can be written as 3Q minus P upon 15 equals to root over 2. Right? Now almost we are done. Now what is given to us? What is given to us? Root over 2 is irrational. It is already given to us. No need to prove that. So this is irrational number. It is already given. Now if right hand side is irrational number, this tells left hand side is also irrational number because there is equals to. So which tells this is also irrational. But is it true? Let us try to check it. Now what are P, Q, 3 and 15? Here P is integer, Q is integer, 15 is integer, 3 is integer. Now one thing you have to understand, when you multiply two integer, you will get integer. When you subtract two integer, you will get integer. When you multiply two integer, always you will get integer. That means this numerator is also an integer. This denominator is also an integer. So left hand side it is nothing but integer upon integer. So this is your integer and this is your integer. So integer upon another integer will be nothing but rational number. So this will be a rational number. So here we can write 3 P Q 15 are integers. Therefore 3q minus p by 15 is rational number, right? But it is showing it is root 2, which is irrational. That is not true. One irrational cannot be equals to rational. So which is not true, we can write. So why it is not true? Again, because of our assumption. Assumption was wrong. So I have to change it. Now I should write 3 minus 15 root over 3 is not a rational number, but it is irrational number. Right? So let us do some more question. Let us do this problem. This is 3 bells toll at an intervals of 9, 12 and 15 minutes respectively. If they start tolling together, after what time they will next toll together? Toll means to ring, right? If the bell is ringing, there are 3 bells. Let's say A, bell B, and bell C. Now, one bell is ringing after every 9 minutes. So, after every interval of 9 minutes, this bell is ringing. And this bell is ringing after every 12 minutes. After every 12 minutes, this is ringing. And after every 15 minutes, bell C. 15 minutes it is ringing. Now, the question is, already they have rang once together. After what time? How much it will take for bells to ring together? That means after what time, after how many minutes they will ring together. So in this type of problem, what we have to find is time taken by the bells to toll again together. Will be equals to the LCM. Definitely it is LCM of 9, 12 and 15. So we have to find the LCM of 9, 12 and 15. At first we have seen how to find the LCM of two numbers, but we can find LCM of three numbers also. It is the same concept. So let us find 9, 12 and 15. First I will find the prime factors. This is 3, 3. 12 can be written as 3, 2, again 2. 15 can be written as 3 and 5. Now what is LCM? LCM is common as well as non-common. So what is common first of all? 3 is common and nothing is common. So what is LCM? LCM equals to, I can write common is 3 and what is not common, that is 3, 2, 2 and 5. So I can write 3, 2, 2 and 5. So how much it will be? 3 times 3 is 9, 18 and this is 10. So 18 and this is 10 equals to 180 minutes. So after 180 minutes, they are going to ring together once again. That, or we can write 3 hours. We can write 3 hours. Because in MCQ, it may not be given 180 minutes. It may be given 3 hours. So you should be able to convert it to hours also. Let us do one last problem for today. That is to complete this tree. Complete the following factor tree and find the composite number x. Okay, there are two parts. First is you have to complete. That means you have to find this. We have to find this x value, y value, and z value. Right? First we have to complete means you have to find everything, and then you have to find value x. Indirectly, the question is saying to complete only. Okay, now what to do? Let us give one example here. Suppose if I write here, what to write? 15. Let us give another bigger number, 75. 75 I have written here. Now 75, if I do the prime factor, now what comes? 5, 1, then carry over to, then 5, 5. Then again 5 times 3, again 3 times 1. Now if I do the factor 3, factor of this factor 3, that is 75. Now let us try to understand the concept so you can do it yourself also. Now this 75 has got two factors, that is 5 if I divide 75 is 15 into 3. So 1 I can write 15 and then you can write 3, right? 15 into 3 is, sorry, 45. 5 into 5 is 25 into 3 is 75. So this is 5 into 5 is not 25. Okay, this is 25. So here I have taken one number, that is 25 and 3. So 25 into 3 is 75. So this is first step of the tree. Now again, this is the prime number. It is not having a factor. So but 25 has a factor. So again 25 I can break. So 25 I can break to 5, 5. Right? So this is way it works. Now how to get, suppose this is missing. Now how to find? Suppose the first one is missing. Let's say this is not given to us. Now I have to find this number here. So what is the concept? To multiply these two. If you multiply these two, I'll get here. Right? Now same thing, let us try to apply it here. Now that is true in every step. For example, see, let us try to complete that. Here. Now this is x. It has got two factor. One is 2 and other I don't. Other we need to find. Again this y has got two factor, that is 3, and other factor also I know. So simply from here, if I multiply this two, I will get y. Right? So let us do that. So value of y will be is equals to, value of y will be equals to 1855 times 3. So this we can write into 3. So this we can write. Okay. Now let us try to find the value of z in the similar way. So 371, that is 371 is has got two factors. So if I multiply those two factors, I must get 371. So 371 must be is equals to 7 times z. So from here z I can find easily, that is z equals to 7 will come down. So 371 upon 7. So I can divide this. 7 times 1, 7 times 5, 7, 5, carry 2, then 3. So this is 53. 53. So this is 53. So here z is nothing but 53. Right? Now y I will get after multiplication of this two. So let us multiply this and calculate x also. So once I'll get the value of y, then x can be calculated as, so in the next step let us see. What is x? X is nothing but multiplication of 2 and y. So 2 into y. Y, I'll get it from here. So let us multiply 3. 5, 3 is 15, carry over 1. 5, 3 is 15, then 1, 16, carry over 1. 8, 3 is 24, plus 1, 25, 1. 3, 1 is 3, plus 2, 5. So 5, 5, 6, 5. 15, 15, 16, 25. Okay, so this is the value of y, and the value of x can be calculated as 2 times y, that is 2 times 5, 5, 6, 5. So easily you can multiply this to get the answer, right? So we will stop here for today and then keep practicing, solve some more questions, okay, and be consistent with your studies, because exams are near. You do not have much time, but then you need not worry also. Take care of your health, study regularly, and do not be tense. Be healthy. That is also very, very important in life. Take care of your health. That is more important than anything else. And don't take too much of stress and practice regularly. So you give your best so that after the exam you will not regret. Okay, don't worry about the exam. I'm sure that it will be best. Okay, you give your 100% effort and don't worry about the result. Definitely after the result you will be happy, and you start working very hard. Right now if you work very hard, rest of the life will be very, very happy. But if you enjoy right now, rest of the life will be very, very sad. So keeping this in mind, please work hard for your board exam and for your life. Okay, we'll stop here. We'll meet later. Thank you.